Hello everyone, I'm Nicolò Cacocciola, PhD candidate in electronic engineering. I introduce my research topic, which focuses on the Lang-on-a-chip technology and their implementation in the analysis of volatile organic compounds for cancer detection. Organ-on-chips are a technology that aims to mimic as much as possible the physiological condition inside a living organism, thus going to thin a barrier between an in vitro and in vivo cell culture, in view of precision medicine. In Lang-on-chips, this translates into mimic the mechanical stresses that normally occur in human alveoli, and in going to reproduce an engineered membrane that simulates the diffusion of gases that physiologically occurs between the alveoli and the blood vessels. My research makes use of the collaboration with three research facilities. The first one is the Candiolo Research Institute, which deals with the growth of clusters of lung cells known as organoids. The second one is the company Biomimics, a spin-off of Politecnico di Milano, which already has experience in the field of organ-on-chip technology. My PhD will also include a research period at IBM in Almaden, California, which has experience in the field of VAX detection for biological applications. The work I did during my first year was to design and build an experimental setup for the mechanical stimulation of lung organoid cultures. In the picture, we can see the block diagram of the system, which by means of an electronic control unit increases and decreases cyclically the pressure inside the culture chamber by 10% every 5 seconds, trying to mimic the human respiration rate. The construction of the system has passed from the design of the culture chamber and its production by means of a numerically controlled mill machine, and from the design and simulation of the electronic control circuit. The system is meant to have a variable duty cycle and to select the final pressure with which to stimulate the organoids. I made a first test to evaluate pressure leakages from the box in two configurations. In the first one, the box is hermetically sealed with sealing caps. In the second one, I insert the temperature and humidity sensor inside the box, create a feed-through by pouring PDMS inside the fitting where I passed electric wires. In both cases, I increased the pressure in the box by 30 kPa and observing the degassing curves resulting in an excellent seal. The system is designed to work in a cell incubator at a temperature of 37 Celsius degrees. For this reason, it was necessary to monitor any temperature variation inside the chamber during its operation. I made a differential measurement by monitoring the temperature in parallel inside and outside the chamber. I then subtracted the second curve for the first one to desensitize the measurement from intraday temperature variations. As a result, the chamber temperature maintains a constant trend. I also checked the final pressure reached by the system in each cycle, obtaining a constant trend also in this case. The next steps for the future will be to test the system in an incubator with an organoid culture, evaluating the effects. The second step will be to engineer the chips that have already been purchased by Biomimics, making them compatible with the growth of organoids, going to test materials and technologies developed by the Politecnico di Torino. During my research period at IBM in Almaden, the Lang-on-a-chip technology and their experience on the analysis of VAX biomarkers will join, trying to build a device configured for pattern detection to distinguish a healthy cell culture from a tumor one. Thank you for your attention.